Okay, so this is now going to be the follow-up to the intro there. And I'm just going to kind of sketch out there what we were talking about. But I had my fence line as one side of the garden. And then I was talking about the other three sides that I wanted to do with the railroad ties. And as I said, I just wanted to make sure I get the maximum area I can get out of it. But I'm limited to about 44 feet of railroad ties. Okay, so I have border or fencing, whatever you want to call it, of about 44 feet to work with. Not quite the perimeter because we're only talking about three sides there, but I have 44 feet to work with. So if that's all I know, well, I need to start somewhere, right? I don't know what any of my lengths are going to be of this rectangle, but I can go ahead and just call the width there X. Okay, so that means that the width here is also going to be X. Take that one step further, X and X would be a total of 2X for that section of the two sides of the border. So out of that 44 feet, I'm using up 2X on the width, so that sentence, 44 minus 2X, is really what gives me the length of that third side. Okay, so there's my start. Now, I'm talking about maximizing the area. Well, as we know, the area of a rectangle is the base times the height. So in this case, my base is 44 minus 2X. And my height is just X. Multiply that out. That's going to be 44X minus 2X squared. And then let's just put that in a little bit more of a standard form. So let's call our area now Y. That would be AX squared plus BX. And then no value for C, right? So again here, let's just clarify. X is going to be the width or the height of this rectangle. And then Y is going to be the area of this rectangle. Okay, so I'm going to kind of scroll up here and just kind of keep working with the numbers now that we have it into a quadratic equation. So from there, think about what it is we're talking about, right? Well, if I have my X as my height, and my Y is my area. So this is my area. This is my height. So I want to maximize my area. So I want to know where can I make that area the biggest that fits within the confines of that equation. So a couple things to think about. When we look at it as AX squared plus BX plus C, first of all, you have a C that is 0, so that's your y-intercept, right? And then you have an A that is negative, which means it's going to open down. So even though I don't know exactly what this looks like, I know it's going to look something like that. So that gives me a good start. So if I want the biggest area on that curve, it's going to be this point, right? Which would be my max. In this case, that is your vertex. So really what we want to get out of this equation is the vertex. Well, if you're talking about it in terms of a quadratic form, we're already there. So you can do your little formula, negative b over 2a. That would be a negative 44 over 2 times negative 2. That's a negative 44 over negative 4, which is a positive 11. And then, as you know, you plug that back in. And this is something you can do on the calculator because obviously the numbers here are going to get a little big. But you can work with that right there. So 11 squared is 121 times a negative 2 plus 44 times 11. And that is going to give you 242. So that is, again, how you would find the vertex out of quadratic form. And that means that right here, when your x, in this case the height of your rectangle is 11, you're getting an area that is 242. And that being the vertex is the maximum area you can get using that 44 feet of railroad tie. So that's kind of it in a nutshell right there. I do want to do one other thing though, so I'm going to go ahead and just grab this equation from right here. So bear with me here. And I want to just scroll down here because there is another way to do this. So we worked out a quadratic form, right? You can also from here go ahead and put it into vertex form, which isn't going to be too bad. Okay. Remember, when you have that A and you're trying to get it into vertex form, you have to factor that out. So I'm going to factor out a -2 here and here. Don't have to worry about the +0 in this case. So that's going to give me x squared minus 22x. And then you're trying to figure out, okay, what do I have to plug in there to get my missing c value to make this a perfect square trinomial? You do your b over 2 squared. B in this case is a -22. That's a -11. Squared is 121. So you're going to have to add 121 right here. And then here's where you have to be careful. Whenever you're going from quadratic form to vertex form, and you have to factor out an a value, keep in mind, I'm not just adding 121 to the right side. I'm adding -2 times 121 to the right side, which is a -242. So I have to add a -242 right there. Okay, so that's now -242 plus y equals -2. And then I already know that's a perfect square trinomial, which is going to be x minus 11 squared. And then last thing left to do is just add that 242 over. And now you are in vertex form. And your vertex being h comma k, h comma k, and once again, that's the vertex we talked about up top, 11, 242, which is maximizing the area using that 44 feet of border fence that I have available. So if we wanted to take this one step further and actually construct it, well, I've just determined that my x is 11, right? So I know what the two sides are going to be. And then 44 minus 2x would be 44 minus 22, which would be 22. So those are the three sides you would do, and obviously you can kind of check the work, come full circle. 11 plus 11 plus 22, there's your 44 feet of fence line, and that works out pretty good. Okay, so let me see if I can just do that for you real quick. I don't know if that's helpful or not helpful, but there's all the work showing why I just kind of set you up. I'm okay with you doing either. It would be great if you do both. So find your vertex out of quadratic form and find your vertex out of vertex form. That would be kind of like going the extra mile on this one. But you want to maximize it. So kind of get a little bit of a sketch, get an idea of what it looks like. Go ahead and maximize it. And what I'm going to do is I'm going to give you up against a barn. So this is going to be your problem here. Okay, you are up against a barn. And I'm giving you 100 feet of fence to work with. So I want you to take it from there go ahead and maximize it. What would be the dimensions or the lengths of those sides of fence? So you're coming off at something like this. This is your fencing. Okay, what would be the lengths of those sides of fence to maximize the area? Okay, so that's your task for today, which is now Thursday. And this one will be due Monday night. Okay, good luck. And if you have your own project at home that you actually want to do, and you want to kind of work off of your own specifications, then by all means go for it. Okay, if you're working on something at home and you want to try this out with it, I'd be more than happy to take that work. But otherwise, just use this one. You're trying to build up against the barn. You have 100 feet of fence to work with.